Hi, it's Rob Asher from Giraffe. I just want to go through this system we've been building for a research project called Urban AI with the UDIA, which I'm pretty excited about. What we're looking at is how to parametrically generate city, built form, um, social infrastructure, parks, schools, hospitals, uh, completely completely automatically. So we have this north-south rail corridor with these station locations that have been nominated. They're sort of essentially arbitrary to the script. Not essentially, they are completely arbitrary according to the script. The green represents constraints, so you can see a flood layer there, you can see a noise contour there, and we're focusing on this station here, which is sort of station number 15 on the line. We're using the OpenStreetMap API to pull the existing road center lines, and then we're allowing the user to draw these blue lines to be new roads which they want, which the script will respond to, but the script will also generate its own road network as well. And then basically what the script does is the center of the circle, of this sort of green circle you can barely see there, is the station, and the script places built form within 800 meters of the station, and it places residential built form and tries to actually create built form that is representative of what a residential floor plate is, as well as commercial built form, which the user can control using these curves here. So this curve is a commercial zoning, and if we pop that right in the middle there, then the entire central area of the precinct would be commercial, and you can see that the built form footprints have changed, and the towers there are much bigger, sort of commercial towers. So there's quite a high degree of parameterization in the script. I think sort of, there's about 5 or 6 parameters, but we're getting. I'm pretty happy with sort of the variety and sort of realistic built form we're getting with these very few parameters. So let me just go through those built form parameters. And here they are really. There's slightly more than this, but these are the 3 main ones. It's an FSR control, a max podium height, and a maximum height control. The way we deal with them in Grasshopper, sort of, we come back from here, create the lots, do something else here, split large podiums, create the podiums here, and then really drive the built form with these controls here. They do it in two steps. The first step is they map the distance from the station to the cadastre in question, and with this downward fall. So cadastres close to the station have this high FSR, and as they fall away from the station, they get this lower FSR. Same with podium height and height. And then to make things a bit easier, we just multiply them by a factor, which is arrayed here, and we're dealing with station 15. So if we were to change the mapping of the height a little bit, ever so slightly, and then change the FSR factor, we will see a big impact. So I think that's 15. So if we see 5, so instead of multiplying the FSR by 2, we're multiplying by 5. Then instead of multiplying the podium height by 1, we multiply by 2. And then instead of multiplying the height by 1, we multiply by 2. You can see that the built form really starts to take off. So as each of those constraints is limiting. So even though, the FSR, by multiplying it by 5, if we go and actually look what we're getting, the maximum FSR around the station is now 15. If we lower the height control to that 1, the script will determine that you can't achieve the full FSR, so the height becomes the limiting factor. So these constraints are sort of AND constraints, so all of them have to be true in order for the script to place height. So that's the built form. The next thing that we do is we can change use depending on how close it is to the station. So as we change that toggle there, you can see that the mixed use podia, or the podium become blue, or become commercial, and that allows you to sort of say, well, within the precinct close to the station, let's have the ground plane really active before we slide to a pure residential mix. And then the final thing, which I'll sort of talk to, which has been quite cool, is been this mess over here, which is the production of a social infrastructure allowance. And I know there's a sort of a scientific method of, you take the FSR, you take the number of people that you're going to put on a area, and you can multiply it by a factor. I think it's number of people, or people per hectare divided by 1 plus factor, something like that, in order to generate the right number of amount of open space. What I'm actually doing with the Python script here is just literally taking the built form and then looping through every cadaster, counting up the number of people in each cadaster, subject to these assumptions, dwelling size and a person per dwelling. And then if the cadaster, if the space required gets too big, it just turns the next cadaster into open space and then continues on the loop in that way. So what we can do is with this control here, the space per person, which I've set to 10, which is low, is run that. So if we crank that to 28, you can see a bunch of cadasters turn into green. So I'll do that a bit slowly. So you can see that as this slides up, cadasters start getting punched out. Now, unfortunately, the script's not smart enough to keep those parks out of the industrial zone yet, but we'll get there at some point. And as I do that, you can see the total population falls, and that's because these cadasters here, which used to be residential, have now been converted to open space in order to achieve that number. So this calculation does include the open space from the constraints, so we minus those or use them fully, and when they're fully used, then we start eating into our residential space. And it does exclude this sort of private open space in these kind of mixed use lots. And it's the same thing with schools. So I've got 6,000 people per school, and if we change that, we'll get more schools appearing. So now you can see I've got sort of the reds of the schools. 1,000 per school. We're getting schools all over the shop. And of course, that person per school could be used person per sort of whatever bit of social infrastructure you kind of wanted, dentists or anything. Yep, so that's, I think, the full scope of what I wanted to explain. I think the discussion I wanted to have is just how nice it is controlling multiple, like a multiplicity of variables using sort of these high-level factors. So using just FSR, some key ratios, social infrastructure ratios, and and nothing else, you're able to generate like quite a lot of built form. So if I send the space per person up to 30, and then we crank the height and allow it to come back up, so hit 2, what happens is the population jumps, and the number of sort of open spaces also has to jump. I have to get out of this mood, out of this view, into this non-rendered to see. So the population jumps by 1,000 in the center, but then it actually doesn't jump as much as you would have expected, because it starts knocking out basically all of the residential around, because the open space requirement dictates that sort of these guys need all the space over here. So understanding the connection between the requirement for open space and sort of the population density is interesting, but also just the built form, sort of the kind of built form that or built form outcome like this feels like a very different place to the place that we had just before when we knocked that down to 1. Sort of this is much higher, but also kind of more beautiful, more like an integrated farmland, where this is much more of a suburban carpet. So it's been a very interesting sort of way of exploring urban form, and a surprising way even for me. And I think the final thing I'll say is I think it's probably better than, if I say so myself, than a series of maps that are generally unconnected. So, if you do zoning, height of building, FSR, and some other maps as sort of separate entities. You then try and intersect them or present them to the public in a way they can comprehend. It's almost a losing battle. It's very, very difficult to do. So at least with this, what you get is an actual city that you can look at and say, look, that's about how much park you get. So you're sort of plugging into people's visual cortices. You're leveraging their intuition in a way that that you're not when you're dealing with sort of flat maps or static processes. So by there I've just cranked the height of building and the podium height, and you can see these little towers everywhere, little residential lots in a much greener sort of city. Like this is something you could have a discussion about. The public, may sort of be entranced by this vision of these kind of paddocks or this basically continuous parkland, but with residential towers, and then with a sort of a monster city around the station, which may, this is sort of a surprising outcome to me. I wouldn't have picked this, but to be able to explore that design space is really interesting.